Alright, I'm going to start first with explaining what integration basically actually is. So there are two kinds of integrals. First you have the integral where you have a number a and b integrating some function f of x. So what does this tell me? Well, let's say that our function f of x is x squared. We all know that the graph of x squared roughly looks like that. It's basically a parabola. Now a and b are values of x, right? So this is our x-axis, this is our y-axis. A might be, somewhere like right here, and b might be right here. So what this will give me will be some kind of number, right? When I evaluate this function, it'll give me a number. That number is basically the area under the curve, okay? So this is our curve, y equals f of x, and I'm saying let's imagine f of x is x squared, and a and b are some numbers on the x-axis. This area under the curve from a to b is what this integral gives us. So if, for example, we had the integral from 1 to 3 of x squared dx, what does this come out to? What number do we get here? The number we get, well, first we evaluate the integral. The integral of x squared, as we all know, is x cubed over 3. Right now we don't write plus c for this because this is a definite integral. It has a number from 1 to 3. So x cubed over 3 from 1 to 3. This is the notation that you denote it as. Now the next step is to plug in 3 for x. So you get 3 cubed over 3 minus, now you plug in 1 for the x. So 1 cubed over 3. And this is obviously 3 cubed and 3, so it's 3 squared, so 9 minus 1 over 3. And when you plug that into your calculator, you'll get a number for that. This number, 9 minus 1 over 3, 8.67, is the area under the graph of x squared from 1 to 3. And now you know what a definite integral basically is. So an indefinite integral would be the integral of x squared dx with no numbers above or below the integral sign. So this would be evaluated as x cubed over 3 plus c. Okay. Now the next thing that we do is, what we need to do is we need to understand estimating techniques. And what I can see is there's a midpoint rule, a trapezoidal rule, and a Simpson's rule. There's a couple of things. The one you need to know is the trapezoidal rule. But before we get to that, there was something that you didn't understand quite well, was U substitution. So I'll make a separate video for U substitution. Here I'll teach you the trapezoidal rule. And apparently for the trapezoidal rule, you need to know the midpoint rule. So first we'll learn the midpoint rule. Now in the midpoint rule, what you do is you divide this graph. Let me make it bigger so I can help you understand it. This is how the graph of x squared looks in the area we're concerned, right, from a to b. Right, this is y equals f of x equals x squared from a to b. Now this area that we're concerned for from our integral of f of x from a to b, this is the area that we need. In the midpoint rule, what you do is you divide this interval AB into n subintervals, right? So n subintervals, n can be any number. So n subintervals, that means that what you do here is delta x, or the change in x, right? This is your x-axis, this is your y-axis. The change in x is equal to b minus a divided by n. Okay? So the problem I tell you to divide this up into 4 intervals, so then you would do b minus a, whatever b and a are, divided by 4. So let's do something with actual numbers. So let's say we have f of x, integrate that from, actual numbers, right? So x squared is our function, x squared dx, from 0 to 4. And say that the problem tells you n equals 4. We want 4 intervals, right? So then delta x is what? B minus a divided by n. So 4 minus 0 divided by 4, which is 1. So that means we're going to have 4 intervals of value 1 each. So let's look at how that looks on the graph. So this is our x squared from 0 to 4. What we're going to do is we're going to divide this into 4 intervals of value 1 each. So this is one interval, this is another one, this is another one. Okay, simple like that. Now for the midpoint rule, what you're concerned for is the middle of each one. The middle of each one, right? So I'm going to use a red pen to denote the middle of each of the delta x's we made, right? It's from 0 to 1 was 1 delta x, from 1 to 2 was another delta x, right, and so on. The middle of each is denoted by the red line on my graph. There's no pausing function. Okay, then okay. So then what is the value for the middle of each of these? Well, we know, right? This first line, this first red line is 0.5, right? Between 0 and 1. The second one is 1.5. The third one, this third red line between 2 and 3 is 2.5. Okay, so then the formula for the midpoint is integral from a to b of f of x dx is approximately, this is an approximation technique, delta x times f of x1 plus f of x2 plus so on. And x1 and x2 are these values in the middle. Alright, so for our problem, what is it going to be? Our problem is integral from 0 to 4 of x squared dx is equal to approximately delta x for us was 1. Right, then we have f of x1, so f of a half, f of 0.5 plus f of 1.5 plus f of 2.5, and this one between 3 and 4 was 3.5, so plus f of 3.5. Right, so when we do this evaluation, this is going to be, what's f of a half? So half squared, right? So 0.5 squared plus 1.5 squared plus 2.5 squared plus 3.5 squared. Right? Where am I getting this from? I'm plugging in each value into our function f, which is x squared. So 0.5 squared, 1.5 squared, so on. And the number we get is 21. So notice this gave us an approximation for this as 21. What's the actual value? Integral from 0 to 4 of x squared is equal to x cubed over 3. And you plug in 0 and 4. So when we plug in 4 cubed over 3 minus 0 cubed over 3, you get 4 cubed divided by 3 is about 21.33 and so on. So notice that this midpoint rule gave us a very, very close approximation and is a very successful way of doing it. So this was the midpoint rule. Let's go over it one last time. So I came up with the question. I gave you the definite integral and I told you n is 4. Right? So that means we need 4 intervals. So to find how long each interval is going to be, you do the top minus the bottom, 4b minus a, divide by n. And I got each interval has to be one value of x. So I drew out the graph and I noticed that, you know, to make 4 intervals is actually very nice for this problem. I did this on purpose to make it simple. And then for the midpoint rule, you take the midpoint of each interval. So the midpoint from the 0 to 1 interval was 0.5 and so on. Then I plugged it into the equation. And the main equation for the midpoint rule is this one. So I'm going to do one more problem using midpoint rule just to make sure that you actually grasp the problem. So let's say, I'm going to keep using x squared because it's easy to graph. Actually, no. This time I'll use e to the x. Right? Integral of e to the x dx from, say, 0 to 10. And let's say this time they want n to be 5. Okay? They want 5 different intervals for your estimation. So then you find out what delta x is. Delta x is equal to 10 minus 0 divided by 5, so that's 2. That means that on your graph of y equals e to the x, it's been a while since I've seen how that looks. Okay, right, so e to the x looks something like this. Right, it's almost like x squared, but moved over to the left. This is your x-axis, this is your y-axis, this is the function y equals e to the x. Now, from 0 to, let's say right here is 10, if I need delta x to be 2, I'm going to count by 2's, right? 2, 4, 6, 8, 10. Right? So these are my estimations right here in the blue lines. Now for the midpoint rule, as I told you, you're concerned with the middle of each estimation. Right? So these red lines I'm making are the middle of each estimation. So what's between 0 and 2? This is 1. Between 2 and 4 is 3. Basically, you can understand these are even numbers. This is going to be all the odd numbers, 1, 3, 5, 7, and 9. right? So those are your values that you have to plug into your final equation. So remember again, the equation was that the integral of 0 to 10 e to the x dx is approximately equal to delta x, which is 2, times f of 1 plus f of 3 plus f of 5 plus f of 7 plus f of 9. Right? So now when you plug everything in, you can get the number, right? F of 1 is going to be, okay, so this is approximately 2 times e to the 1 plus e cubed plus e to the 5 plus e to the 7 plus e to the 9. And when you put this in your calculator, you get a number of the approximation. And that's your answer. Easy. This is the midpoint rule. Now the trapezoidal rule is not significantly more different. So now we're going to do the trapezoidal rule.